Good afternoon, guys. So I think we are good to start the session now. So today's topic is introduction to machine learning and linear regression. Is my screen visible, right? Does anyone confirm whether my screen is visible or not? Yeah, is my screen visible? Yeah. So basically, in the last week of the sessions, you have been learning about the data analysis part, which is nothing but when you will be given an input data. Let's assume you are given a CSV file. So basically, what in the last week we have discussed is that using pandas, how to import that CSV file, and using data pre-processing and data cleaning and EDA to get some of the insights, like some of the major relationship between some things. Uh, that's it, right? So in this week of sessions, we will be discussing about the machine learning models. Here in the flowchart, you can see the first part was data extraction and analysis, which includes all the data analysis parts like inputting the data, removing null values, and pre-processing and getting some insights from EDA, etc. And after that, we will be providing this data to a model, and we will be training the model. So what will the model will do? The model will take the data and perform uh, it will predict the new outcomes of unseen data by using the seen data. This was the main aim for the machine learning. So let's start to know some basic terminologies of machine learning, like what is machine learning and etc. Those all stuff. So basically, this was introduction to machine learning. So can anybody say me what does learning means? Like you might be saying after the boot camp that you have learned machine learning, right? What is the term learning means here? In semester one, you have learned about the C, right? How are you able to say that I have learned C? Like what is the word learning means here? Can anybody say me? Anyone? What is the meaning of learning? Yeah, you were exact to the point. So we will be saying a person is learning something when if what here just a second. Like after learning, a person should improve its performance on a particular task. Like before learning C, you will be you are not that familiar. After the C course, you have now good familiar with the C programming language, right? Here also it's the same thing. Here the agent is computer, so here we will be calling it as machine learning. So what does the machine learning do? It will observe some data and build some model on the data, so that in future if there is any problem regarding the data, the model is ready to assist that thing. Is it clear, right? Like what is learning and what is machine learning. So the next point is why we are using machine learning. So basically, we are having some traditional programs, right, to predict for the regression and classification, which we are going to discuss also. We have some traditional models, like you can write a C program to convert a string into a integer or something like that, right? Then why we are using machine learning? Why we want the machine to learn? We are able to do everything using the traditional programming, right? Like you can also see that machine learning was introduced in the era of 2005, in that era I think so. Till then, we are using only the programming languages like C, Python, etc. Why there is a sudden shift towards the machine learning? Can anybody answer about this thing? Why we need machine learning? Like using traditional programming languages like C, Python, C++, we can able to do many tasks, multiple tasks. Anyone? Uh, so the thing is that for the traditional programming, we can do the traditional programming for some data, some less data. But coming to the machine learning part, we can able to incorporate more data. So that is one of the reason, and there will be many other reasons too. Basically, so here you can see machine learning was a study of computer algorithms that improve its accuracy automatically through experience. Here they're also used to find the statistical patterns in the massive data. Here you can see, right, about we cannot apply the traditional data like traditional programming like C, C++. Like we are having a data set of 1,000. We can do by using both machine learning as well as traditional programming. But in the real life situations and real life data, the data will be in some billions in that massive amount. So it's better to use machine learning. It is better to shift towards the machine learning instead of traditional programming languages like C, C++. So basically, this is the major example of traditional programming and machine learning. So basically, in traditional programming, we will be giving the x values and y values, like the condition which we want, and we will be getting the answer, right? It might be y equal to x plus 2, something like that also. But what machine learning will do, in the machine learning part, we will be giving the question and answer. It will find the relationship between the both of the variables. Here we are giving the data as input variable, and we want a particular value as an output. We will be giving those two and training the model. What model will come to an interface? The model will come to an thing that here we are using y equal to x into 2. That thing. So is it clear, right? Like what is machine learning and why we are using machine learning over traditional programming? So basically, in what all task we will be using the machine learning part. So the first one is email spam classification. Like nowadays in our Gmail, we are directly getting this feature, but in past 5 to 6 years before, we are not able to get this feature. Like nowadays, the email which is spam, it's directly go to the spam inbox of our Google. But what we have to do, like we are preparing an ML model to detect a spam, right? How will be preparing the ML model? We will be giving some sample data set. We will be training the model on some sample data set. Like just a second, I will be sharing the code which I have done. So are you able to see my GitHub repository thing? Yeah, okay. So here you can see, like this is the email spam classifier which I have done. So basically here we will be giving an input data, and what we want is output. Like here you can see there are two rows, that is category and two columns, category and message. For the first message, it is ham, means it's not a spam. We can go and read for it. And coming to the fourth, in the fourth row we are having free to entry in a two weekly compose to win a that thing, right? By seeing itself only we are able to know that it's a spam email, right? So this is the data set. Here we are having some around 500 or something. We will be using this data set and training a model. Now what the model, like, let me show you the code also. Like what the model will do means, after training we will be giving a new input, a new unseen input. It will predict whether the mail is spam or not. So here you can see I have imported the mail.csv, and I've done some pre-processing part, and I have trained a logistic regression model on this. Here you can see I have created a new thing, like I have given a new input. Here you can see the prediction was 1. The prediction was 1 means it's not a spam. So basically the machine learning works. We'll be giving input variable and what the output we have to get for some particular things. So as an output we will be getting whether the email is spam or ham. Like, it's clear, right? The email spam filtering. We can also use the machine learning for the audio purposes and text to translation, and we can also use it for recommendation systems, etc. We'll be discussing all of those things in this bootcamp, in this 1 week of bootcamp. So basically machine learning, just a second, machine learning is divided into 3 types. One is supervised, one is unsupervised, and another is reinforcement learning. So coming to supervised learning, it's again divided into 2. One is regression and one is classification. So what is supervised learning? Like we have studied about the email spam classification, right? The definition, the formal definition of supervised learning is that it will see some extents, like let me show the slide. Initially we will be training the model on this, like this type of data set. Like if there is a data which is under this line, we can say it as S, and which is the data which is above this line, we are saying it as no. So the supervised learning is nothing but we are learning from some data. Like in the previous case I have trained the model on some data, right? Like some 500 rows of data, right? So initially I am providing all of the conditions and making the model to be perfect and predict the upcoming one. And while coming to the unsupervised learning, in unsupervised learning we are not having any of the predefined data set or rules for training the model. We are just adjusting the parameters and something, so that we will be getting the output well. So here you can see these all our examples of a regression task. Sorry, you have understood the difference between supervised and unsupervised, right? Like, is there any confusion between the supervised and unsupervised? If it's done, we will be going into regression, classification, clustering, and dimension reduction. Any doubts in supervised versus unsupervised? Okay, I think you have understood. So basically, while coming to the supervised part, we are having 2 different types. One is regression task and another one is classification task. So what happens in the regression task? In regression task, we will be having some data, and for unseen data, we have to predict. So let me show this example for you. So here for the regression task, it is an example for house price prediction. So basically here we can see that there are 1 2 3 4 5 6 7 8 9 10 11 12 13 samples were there. Like we have the price versus house size. So for 499 or something like that, the price was $100, something like that. So we are training our model on this 13 data sets. Like for suppose my house size is 3000. So my trained ML model will be predicting the price of the 3000 based upon the inputs which I have given for these 13 variables. So based upon these things, based upon these relationships, it will be generalizing some equation. So basically, in the previous example, we have seen that we have given x values and y values, and y equal to x into 2, we are getting an output, right? So here also the same thing. Here we will be getting a relationship between the house size as well as price. So for the new sample, if you given any one of the variable, either price or house size, we will be getting the another variable too. Like this is a basic example of regression task. Coming to classification task. So basically, classification is nothing but dividing a particular instant into two or more different type of classes, like dividing a human being into male and female, like that, based upon their characteristics. Here also, based upon the tumor size, tumor diameter size, we are dividing the breast cancer cells into two different classes, whether they are malignant or benign. Malignant means they are highly affected by the breast cancer, and benign means they are not that much affected by the breast cancer. The cells which are not that much affected by the breast cancer. So I think we have covered the regression and classification, right? Like any questions regarding this regression classification? Okay. Now we will be discussing about the unsupervised part. In unsupervised part, we will be having the dimension reductionality and clustering. So first discuss about the clustering part. What is clustering? How many of you have your Netflix account here with you? Amazon Prime Netflix account? Please raise your hands if you have your Amazon Prime Netflix account. No one. I'll be not asking the accounts, just raise your hands if you have the accounts. Okay. Are all downloading the movies from Movie Rules or what? So basically, or do you use Netflix? I think most of you people will be using the Netflix in this generation, right? So basically, in Netflix or Amazon Prime, when you see a movie, you will get a recommendation, right? Like when you see some movies for over a week, over a month, you will be getting some Amazon recommendations to watch this movie. Like based upon your preference, you will be given this movie. Like try this movie. Your choices matches this movie, something like that, right? So it's basically worked on the clustering part. So in the clustering part, the machine learning model sees your observation, like it will observe your observation, like how like which type of genre movies you are seeing. You are seeing horror movies or thriller movies, something like that. And after some time, like after 2 to 3 days, it will understand that you like this type of movies, so it will try to recommend that type of movies itself for you. So once you try, whether in your Netflix account, if you try to see all thriller movies for 10 days, you will be getting the recommendations of the thriller movies itself. So that's the thing of the clustering part. And coming to dimensional reductionality, so just a second. So coming to dimensional reductionality, like for some machine learning models it's okay, but some machine learning models will be depending, here we can see that regression model is dependent upon only two variables, uh, size and price, right? Like in some cases we will be having so many parameters. We'll be using the dimensional reductionality concept to reduce all those parameters. Okay, and coming to the most interesting part, which is reinforcement learning. Anybody heard about the reinforcement learning here? I think it's a popular field. So in reinforcement learning, an agent will be there like us itself. Like the agent will be trained. the similar example, like okay, uh, here when we take a course in Sri City in our college, we will be given some graded assignments, and we will be given some quizzes, surprise quizzes, and we will be giving some mid exams, end exams, and lab exams, and we will be graded, right? Here also, for in reinforcement learning, there will be an agent, or you can call it as a robo. The robo will be given a particular task, like to acquire this reward, the robo has to perform this task. Like if you want O grade in a subject, you have to work hard and you have to get around 70 plus in your total score for 100, right? So here also, in reinforcement learning, a agent must satisfy some of the conditions so that it will get some rewards. So for getting the rewards, the agent is trained in such a way that it must get rewards. When he will get rewards, when his score is above a particular threshold, he will be getting the rewards, right? So based upon that concept, we will be training the reinforcement learning things. So I think I've covered everything. Let me revise. So basically, introduction to machine learning. So you have understood what is learning and what is machine learning, and what is the difference between the traditional programming and the machine learning part, and you have understood about the basic things of machine learning, like basic applications of machine learning, and regression and classification task, which comes under the supervised learning. You are aware of that thing. Like in classification, we can also classify a particular thing into two or more classes. After that, supervised learning means you are learning from a data labeled data with right answers. When coming to the unsupervised learning, you are not you will initially you are not knowing what are the user preferences and etc thing. By going through some for some time, you will be like the person likes this movie, and you can use those things for the recommendation. So basic terminologies in machine learning. So here we have discussed, right? So for the supervised learning, we will be having the labeled examples. Like for this particular input, we will be getting that output. But for the unsupervised part, we will be having only the input, but we are not having the output. Like the output will be output will be decided uh, upon some time, like upon observing the person for some time. So I think now this thing was clear, right? So first, initially, we will be taking the data, extracting it, and getting some insights from data. And after that, we are passing the data, the .csv file which I have shown in you as an example, to a model, and we'll be training that model. And we will be evaluating that model, like we have to do evaluation for the model, right? Whether it's predicting correct or not. And after that prediction and evaluation, we will be training the trained model. And we will be evaluating the trained model. And the trained model we can use anywhere where we want. So here you can see these are all the examples and applications of machine learning and machine learning. We can use the machine in so many parts, like handwritten recognition, speak recognition, face scan detection, face detection, everything. And you will be thinking that machine learning is only related to Python and R. Here you can see that machine learning is not only related to only Python or computer science. It's related to many fields. Like here you can see machine learning is only related to one field, and those all stuff. But in reality, machine learning is everywhere. You can use it in the field of biology to it. We can use it in the field of chemistry, physics. In every field, machine learning is applicable. So coming to the relationship between AI, ML, and DL, this is a most important relationship one should understand. So let's come from the deep learning part, or shall we start from the artificial intelligence part? Okay. The first broadest thing was artificial intelligence, right? Like we will be discussing what an artificial intelligence can do, which machine learning and deep learning cannot do. So basically, how many of you have Alexa, like heard about Alexa and the Siri you will be having in your iPhone, right? Those are your personal assistants. Those are dependent on artificial intelligence. They are built on artificial intelligence. They will be having tasks like speech to text, and from text they will give some response, and that response will again convert it into the speech, and those all stuff will be done, right? It will come into the artificial intelligence part. And next, coming to the machine learning one, the email spam classifier which I've discussed, which will come into the machine learning part. And coming to deep learning part, the main example of the deep learning is, for unlocking your system you will be using your face ID, right? It might be in Android or it might be in Apple. The face recognition and face detection is a major thing. They're only not the one thing which is there in the deep learning. There are many concepts, but for you to get an overview, these are all tasks which is differentiating the AI, ML, and DL. Okay. So here are the some popular algorithms, like for the classification and regression, both supervised and unsupervised. So linear, logistic, and polynomial regression are very much important in supervised techniques, and for the regression supervised. And these are all algorithms are very much useful for the classification part. Okay. I have come to an end. Like I will be discussing a short story of Facebook, which they have used for object recognition. Like how many of you use Facebook here? No one. No one have ever used the Facebook here, even for some time. Raise your hands if you have used a Facebook here. No one. Instagram? How many of you have Instagram and using Instagram here? Okay, okay. So basically, how many of you know, like, how many of your parents or something used, like, don't you know about Facebook, like a bit of Facebook? So basically, in Facebook part, initially they used the zonal detectors, like wireless zones detectors. What they used to do, they used to frame a box around a particular person. Initially, when it's around 2010 or 2011, we had a feature in Facebook, like if you upload a group photo, the Facebook used to ask the email ID, like the username of the person, right? Like if anybody heard about thing. So what the Facebook done, like it taken the user input, like this person is Sriraj, this person is Yashwan, this person is somebody, like that. And after few days now, after the Instagram is taken over by the Meta, now we can see that if we include, like if you upload a group photo, it's directly saying that this person is Sriraj, right? This person is Yashwant, right? It's saying like that, right? So the base idea is that the Facebook have used these detectors and asked, in initial days it asked us to give the username of the particular face. Uh, After some time, it's trained the ML model on the particular username, come the features of the photograph. And nowadays, the Instagram, we are getting the notification that when we upload a group photo, is this Anand, right? Is this Abhilash, right? Something like that. So by this I came to the end of my presentation. Thank you guys. Like if you have any questions about the regarding introduction to machine learning, you are okay to ask me. Like we'll be starting the linear regression part in 2 minutes. If you're having any questions, you may ask. Otherwise, we will be starting the linear regression part. I think no other doubts, right? Like if there are any doubts, please say or type in the chat box. Now Charishma will be saying about the linear regression part. Okay. So if you have any questions regarding the introduction to machine learning, you are feel free to ask your questions in the chat box. Okay. Okay, Charishma, you can continue the linear regression part.
So, good afternoon, guys. So, I know it's a bit long session on introduction on ML. So, now we'll dive into linear regression part. So, I'll just share my screen. So, can anyone confirm me whether my screen is visible or not? So, yeah. So, here we are going to cover the linear regression, their types, and also overfitting, underfitting, and regularization techniques. So, now coming to introduction part. So, linear regression is used for finding relationships between target and one or more predicators. It helps us predict y based on x values and understand relation between two variables. As you can see here, this is the equation for linear regression where y is the predicated value of like it is an independent variable and b is the slope of the line, and coming to x it is a dependent variable and a is the intercept of y. So now let's delve into the types of linear regression. So there are three types basically. So one is simple linear regression, multiple linear regression, and polynomial regression. So we'll discuss one by one. So have a look at these general equations for a few seconds. So I think okay. So coming to simple linear regression, so the main idea behind linear regression is to find a line that fits our data points as closely as possible. So you just imagine you have bunch of points scattered on a graph and you want to draw a line through them. So that is you need the line as close to the points as you can get. So we call that line as best fit line. We'll see with an example in upcoming slides. And here is an example. So let's say we have a data set that tells us how many hours a student studies and the corresponding marks obtained in a test. So our goal here is to build a model that can predict a student's marks based on how many hours they study. So here you can see the formula for simple linear regression where y is the predicated value as you know, and b0 is the intercept of the line where it crosses the y-axis, and b1 is the coefficient of x, basically the slope of line, and x is our input variable. And also here you can see the formula for error, which is actual summation of actual output minus predicated output whole square. And also here you can see we can calculate b0 and b1 using these formulas. So coming to b1, this tells us how much the predicated marks change for every 1 unit increase in the number of hours studied. So if b1 is greater than 0, it means that as the number of hours studied increases, the marks obtained also increase. So we know this is a positive relationship. And if b1 is less than 0, it means that the number of hours studied increases, but marks obtained decreases. So this is a negative relationship. So B1 here helps us understand whether studying more hours tends to result in higher or lower marks. So now coming to exploring B naught. So B naught is just as important as B1 in linear regression. It represents the intercept of our line basically. And here there are two cases. One is with including x equal to 0 and another one is without including x equal to 0. So first of all, let's discuss without x equal to 0. So first of all, think of B naught as starting point of our line. But if we don't include any other information as we seen in previous example, like number of hours studied, so then B naught becomes the only thing we are using to make predictions. So it's like saying regardless of how many hours you study, everyone gets the same marks. That's not correct, right? Is that correct? Is that true? Like when it comes to engineering, it's true, but in other cases, it's not true. So without including any other variables, it doesn't give us meaningful predictions, right? So coming to including x equal to 0, so now let's say we do include the number of hours studied as a variable. So, but think about we have some data points where number of hours studied is 0. So, for example, if we are looking at a student who hasn't studied at all, their marks might not be 0. So, setting all variables to 0 might not make sense in real life, right? So, if we include x equal to 0, B naught gives us average marks of a student, even though if they didn't study at all. So here you can see this graph where it is the relationship between years of experience and salary of a person. So basically, we know as years of experience increases, salary also increases. So here we can say this line is a best fit line because we see here as many of the data points are close to the line. So hence we can conclude that our model is good for the training set. So now coming to cost function, it is a measure of how wrong the model is in estimating the relationship between x and y. So like you imagine you have a model that tries to predict something like how much a house will be sold for based on its size, but your model might not always get it right. So the cost function basically tells us how wrong our predictions are compared to the actual values. So in linear regression, we basically use MSE, that is mean squared error. It's like taking the difference between our predicted values and actual values, squaring those differences, and then finding average of all those square differences, as you see in the formula here. So now coming to finding the perfect values of W and B here. So we use gradient descent method, where in gradient descent method, we usually start with some initial values for W and B. So we'll keep on changing W and B a little bit to reduce the cost function. We'll have a parameter here. We'll come to it later. So we'll keep on doing this over and over until we reach a point where changing W and B doesn't make the cost function much smaller. So coming to why do we use cost function? So here in this graph, in this example, this is a relationship between height and weight of dogs and cats. So here it is a distinguishing between cats and dogs based on their heights and weights. So if we plot this, as we plotted these data points in the graph, we get a scatter plot there. So these are the three possible solutions for this classification problem. So in these three solutions, everything has high accuracy, but the third solution stands out as best because it correctly classifies each data point as we see here. So by minimizing the value of cost function, we aim to find the optimal solution here. So there is an algorithm for this that is gradient descent. So it is used to minimize the cost function and find the best solution. So as you see in this picture here, if we when we keep on doing this, that would eventually reaches its minimum thickness, right? So are everyone with me following it? Yeah, okay. So it eventually reaches its minimum thickness, right? As I told before, there is a parameter to reduce the cost to minimize the cost function. So it's the learning rate. So this learning rate is represented by alpha. So it plays a crucial role in gradient descent algorithm. So like let's take an example. So imagine you are hiking down a mountain. So the learning rate is like deciding how big of a stride you take with each step. So if you take two large steps, what happens? Do anyone have an idea about it? On a mountain, if we take a two large step, what happens? So because of its slope and all, uh, we gradually fall down and end up on the other side of the valley, right? So conversely, if you take tiny steps, it might take you forever to reach the bottom, right? So this is the impact of high and low learning rates. So whereas in high learning rate, you move quickly towards the minimum of the cost function, and in the low learning rate, you move very slow towards the minimum. So it will take more iterations to reach the minimum, but it doesn't converge anywhere. So now let's see how gradient descent works. So basically, as you see in the graph here, so we'll basically start with some uh, value, and you use learning rate and update the values. You keep on doing this until you reach a minimum point. So we can basically call this the minimum of the cost function. In this here, the cost function will be minimum. So you can have a look at the algorithm here. This is the algorithm for gradient descent, where you calculate W and B using this and keep on updating them using by changing the learning rates. So everyone understood until here? Is everyone clear? Okay. So coming to advantages and disadvantages of gradient descent. So first, we'll go with advantages. So it can be applied to every dimension and space. So we can use it in many different situations, even when dealing with lots of dimensions or infinite possibilities, basically. And also, it's not too hard to set up. You just need to follow a few steps, like you have seen in the graph beside. And coming to disadvantages, it has a local optima problem. Like sometimes gradient descent can get stuck in places that aren't the best solution. It might miss the very best answer because it stops too soon. So next, it's relatively slow, close to minimum. It means as it gets closer to best solution, gradient descent slows down. It's like climbing a hill. As we climb a hill, as the closer we get to the top, it's harder to keep going, right? So, another con of gradient descent is for some really tricky problems, it might not work well. So now, coming to another type of linear regression, that is multiple linear regression. So here we see in this picture where multiple predicators are influencing y. So here these x variables are independent variables. This influenced the value of y. So in multiple linear regression, we are dealing with more than one independent variable instead of just one factor influencing an outcome. So you can see the formula here, where y is the predicated and x1, x2, all these are independent variables. Those are the things that affects y. And beta naught, beta 1, all these are coefficients, as you know. And epsilon is the error term, as we also have seen how to calculate error. And here in this graph, you can see, so instead of a simple line in simple linear regression, we use a plane here so that it covers all the data points in all the dimensions. So we have some algorithms for this, like PCA, MNIST dataset example, for example. So all this will be discussed later. So our goal here is to find the equation for this plane that best fits our data points. So it's like adjusting the slope and position of the plane to minimize the difference between our predictions and actual values. So here you can see in this equation, if if beta 1 is high, uh, that means x1 has more impact on y. So once we have our equation for the best fitting plane, we can use it to make predictions. We plug in those values we got, and the equation gives us estimate of y. So now coming to the third type, that is polynomial regression. So while in linear regression, it uses straight lines to model relationship between variables. This polynomial regression, it uses curves instead of straight lines to better capture the relationships. So did you understand? So okay. So in polynomial regression, we basically use nth degree polynomial. So here we can see in the simple linear model, this line is not a best fit line because these data points are far to that line. So we can say this is not a good model that we need. So coming to polynomial model with same data points, here we can see this line fits all the data points. So in this, we can come to a conclusion that by using curves instead of straight lines in some situations, it can sometimes reduce the errors, right? So this means we can better fit our regression line to our data and make more accurate predictions with this polynomial model. So now, as we know, coming to overfitting, underfitting, and regularization techniques. So overfitting is nothing but, as you see in the first graph here, it's where x-axis has time values and y-axis has values. So these are the data points. As we see here, this model is too simple. So it's like fitting a straight line to a curve. We see these data points are looking like a curves, right? It's in the shape of a curve. But we used straight line. We used a linear regression here. So it's not a good best fit line, right? So it misses some data complexity. So this is what underfitting is. And when we come to overfitting, we see here it covers each and every point. It has more curves even. So we can say this captures more noise, not the data points. So we can basically for a better understanding, we can basically differentiate between underfitting and overfitting. There are two important terms for this, like the bias and variance. So bias is nothing but as we have seen in underfitting, like the model is too simple, it misses data complexity. So Bias is the same as that, like it measures prediction closeness to actual values. So if we have high bias in a uh, situation, like it means missing some data complexity. So coming to variance, it's like overfitting. Like it measures prediction variability between data sets. So high variance means if there is a high variance, it captures only noise. It doesn't capture the data points, and it does not give us a very good line. So to overcome those underfitting and overfitting techniques, we usually use three techniques here. Like one is L1 regularization, it is also known as lasso, and second one is L2 regularization, also known as RITS, and third one is elastic net. So in L1 regularization, we basically make some of the coefficients to zero. So it means we remove unnecessary features from a model. And coming to L2 regularization, it doesn't make the coefficient to zero, but it shrinks the coefficients towards zero. Like if we have more like big values, so it basically reduces their values and shrinks it to zero. And coming to elastic net, it is a combination of both L1 and L2 regularization. Like it provides flexibility between both. We can basically say that here you can see mathematical representation of three regularization techniques. So this is for L1 regularization, that is the summation of mod of values. And in L2 regularization, you calculate it by summation of square of values. And in elastic, we combine both L1 and L2 together and we get elastic net. So than L1 and L2, we can say here that elastic works better than both individual. So did everyone understand? Do anyone have any doubts? So is everyone clear? Please raise your hands. So okay. So I think that's it for linear regression. So we'll be continuing with logistics and SVMs in tomorrow's meet. So if anyone have the doubts, please ask or put them in chat box. So I think no doubts. Okay, that's it for today.